Okay, hello everybody. My name is Neil Jefferies. I'm Executive Director of the Open Preservation Foundation. Um, about probably 11, 12 years ago, I was a member of the Fedora steering group. But most importantly, I'm one of the editors of OCFL, which is what I'm here to talk about today. And OCFL is one of the technologies that sits underneath Fedora 6. So OCFL stands for the Oxford Common File Layout because it was conceived at a meeting in Oxford. Um, but it's designed to deal with a number of digital preservation problems. One is there are any number of standards, OAIS, TDR, NDSA, etc., which are very good at telling you what to do, but they don't tell you how to do it, and they tend to gradually evolve over time as well. But those of us at the coalface actually doing digital preservation know that digital objects have to outlast the systems that create and preserve them. And one of the most risky times when you're dealing with digital objects is when you're exporting and re-ingesting as you migrate between systems. And really, preservation should not be too dependent on those overlying systems. They should not depend on system behaviors. Objects should stand on their own right. And, I'm preaching to the converted here, but you know that backup and disaster recovery are just not preservation. But digital objects are not just files. The reason we're keeping them, or the economic reason why we're keeping them, is for their information content. And a lot of that information and meaning is dependent on not just on the data, but on the metadata and the relationship to other objects. And these provide context, provenance, and that sort of thing. And all of these things need to change over time. So the object in the broader sense will have to evolve slowly over time. And finally, I think this is quite useful, although it comes from another domain, is the acronym FAIR for findable, accessible, interoperable, reusable. And it's a very good way not just thinking about scholarly outputs, but actually thinking about why we're doing digital preservation and what we need to do in order to make the economic case for digital preservation. And to some extent, it recognizes also that metadata is really critical, and in some cases, more important than actually the data. Knowing that something existed um, is in itself a very important fact. So the Oxford Common File Layout started in 2017. There were discussions a little bit before then. Version 1 was released in July 2020. Then a couple of years later, version 1.1 was released. That did not substantially change the specification in to version 1.0 object. In almost all cases was version 1.1 compliant. But in the light of implementation, we discovered that version 1 of the specification allowed you to do some things that are frankly silly. It permitted some corner cases that weren't really very sensible. So 1.1 tightened up the specification to remove ambiguity and uncertainty in the specification. And what I'm going to talk to a little bit later is where we are with version 2, which is what we're working on right now. Specification describes two things, the OCFL object itself and the storage route, the file layout, how we distribute that object or those objects in a file system type structure. Alongside the specification, and I cannot emphasize this enough, are implementation notes, which describe guidance on how to implement OCFL, but also a little bit more information on why certain design decisions were made, which may help you in implementing that. And in a lot of cases, the questions about how to implement OCFL are answered in the implementation notes. It also gives you an example of how to do operations on OCFL objects in a way that enables you to detect when an update has failed and to be able to roll back to known stable states, and how to analyze objects and determine what the last known stable state was in the event of damage. So it contains a lot of useful information. So what does an OCFL object look like? It is essentially there's a skeleton object shown on the right. It's a group of one or more content files and a little bit of administrative information. Um, OCFL tries to be minimal in the amount of information, additional information it requires over and above that which constitutes the object itself. And together, those have a unique identifier. The object may contain a sequence of versions. You can see in the file structure there's v1, v2, v3, organized, and those are organized in version directories that represent essentially the evolution of the object's contents. Every single version ideally contains an inventory file that details which files make up that version of the object and what their basically content or fixity details are, and a little bit more information about why that version exists, how it differs from earlier versions. It's very important to note that OCFL does not have an opinion as to what a digital object is. You can put anything in there. It's content agnostic, nor does it define what you need to do to create a new version, what constitutes a new version of the object. Those are entirely application dependent. It does have various places in the specification which allows you to include extensions, additional information, additional bits and pieces in the object. And the reason it does that is when you're validating an OCFL object, we know where extensions will be, so we don't need to require those to conform to a particular version of that specification. There can be extended validation that is application specific, but a basic OCFL validator should not require those extensions. So that's an OCFL object. An OCFL storage route is effectively a way of laying out objects in a file system. There's a base directory at the top that contains a conformance specification and ideally a copy of the OCFL specification to which it conforms as well. So as much as possible, the structures we produce are self-documenting, at least at the file system level. Each object in that storage route should conform to either the same version as the storage route, OCFL version as a storage route, or an earlier version. So as much as possible, earlier versions of OCFL objects are compatible with newer versions of OCFL. And the reason that needs to be the case is when we update and add a new version to the object, we should not have to rewrite the earlier versions, even though we've migrated to a new version of OCFL. And that, of course, imposes a certain amount of discipline as to how we structure and evolve the specification. The storage hierarchy makes use of the persistent identifiers of the objects, ideally to locate them within the file system. And every tree or every path within the storage hierarchy must eventually terminate in an OCFL object. So there should be no empty directory sitting in the structure. And again, OCFL storage route structure itself allows you to specify extensions which qualify how you've constructed that storage route in some way. So what are the benefits of using OCFL? And in a way, as well as the benefits, these were design goals that the OCFL editors took on. And that was a result of community consultation at the outset, going into the construction of OCFL. Part of that is completeness, in that a repository should be rebuildable in its entirety purely from the OCFL structure. There should be no data lurking in hidden databases, in places outside. Everything should be described within the objects within the OCFL structure. And this is one of the reasons why a Fedora 6 to Fedora 7 migration doesn't require you to do anything, because all of the information is in the file structure. There's nothing else to migrate. Parsability is important, not just machine parsability, but ideally, because the file structure contains documentation, because it is structured in a rational way, and because the files are designed to be reasonably easy to read for humans, they're JSON based. The idea is you shouldn't need particular software in order to understand an OCFL structure. You should be able to use basic file system tools to understand what's going on there. Robustness, it's got some built-in fixity, and it's got deterministic behavior in the event of damage or corruption of an object. Um, so that hopefully will help you when you're building your preservations to what's going on there. I mentioned before that we believe objects need to be versioned, so it supports versioning, but it always retains the history of the object and it allows you to retrieve earlier versions of the object with relatively little code overhead. It makes relatively little assumptions about the characteristics of your file system, so it is supportable on a wide variety of storage systems, including cloud object stores. And a number of the design decisions have been made with a view to efficiency, computational efficiency, storage efficiency, up to a point, um, and bandwidth efficiency. Some of these compete with each other, so sometimes trade-offs have to be made in the design. So let's drill down into this. I've discussed completeness a little bit. Um, An object within OCFL is stored as a single entity. It combines data, metadata, and history within a single notional object. It aligns with TDR, NDSA, OEIS if you really want to. Um, but the idea is that should be something that is portable in its own right. An individual object is complete in itself and can be migrated from one OCFL structure to another if you wish to. Copying an object is simply a file copying operation. Parsability, I've mentioned, um, partly for disaster recovery situations. If you find an OCFL structure, there should be enough documentation within the storage route, but also some of the extensions also help to include documentation, so that you can work out what the data is and how it's arranged within the system, even in the absence of software. It also allows you to build a very simple application on top of an OCFL structure to access that content, even if you don't need a full-fledged repository. And there are slots within the specification where you include additional documentation, as I mentioned. Excuse me, I got a bit of a cold. Robustness. Fixity is built into OCFL, not primarily as fixity, but primarily as a mode of content addressing. So it addressed files based on digests, cryptographic digests, which are based on the content of that file. What that means is if the file system is corrupted, but we have some inventories and we can retrieve some files from the system, we can use those digests to assign those files to particular objects. So it gives you a degree of rebuildability as well. We do allow multiple fixity algorithms so that the fixity algorithms or the digests we use can change over time. One of the reasons you'll do that is primarily, as a result of cryptographic developments. Some algorithms may become subject to attack or maybe broken or prove to be unreliable. So you will need to change that over time. Inventory is generally replicated. You don't have to, but the recommended way is to have an inventory for every version. And at the top level, the inventory is duplicated. The idea of that duplication is A, it's easy to find the top level inventory because it's the most recent inventory because it's always in the same place, but also having multiple copies going back through the history also improves recoverability. As I said, read the implementation notes. There's a lot of stuff on how to safely do operations on objects and how to recover. Versioning, keeping the history of an object. This is an example of an inventory which has a state of an object, which includes different bits and pieces. But changes to objects are tracked over time as new versions are done, and it uses forward delta differencing. So when you create a new version of the object, you only store the files, the elements of that object that have changed. And the inventory will reference those files in earlier versions if they are unchanged, and that reduces the amount of storage. Excuse me. But because that stuff is all in the inventory, it's very easy to reconstruct earlier versions. It simply is pointing to different paths within the tree, within the object, because the object is self-contained. So it's relatively simple and relatively quick to reconstruct earlier versions of an object. Storage diversity, it does support the conventional file system metaphor, but it only assumes basic file and folder functionality. It avoids the use of any hard or soft links or symbolic links or anything like that because implementations of those in different file systems vary and it can complicate copying and other operations, file storage estimation and other operations. So it doesn't assume that you have links that work in any particular way. But another important part of it is it separates the logical path in an object structure from its actual path on disk. So the object may have within its own structure many folders and many levels, but when they're stored on disk, they can be stored in a much flatter structure. And that allows you to work with more effectively with things like S3 and other cloud operations, which favor flatter structures. Also allows you to store objects which have complexity within them that can't readily be mapped to the file system. Very long path names, unusual character sets, for example. And the inventory holds the mapping between where an object is stored and where logically it should appear in the object. Finally, efficiency, and this is really stating things that are mentioned elsewhere. We can do deduplication between versions of an object because we use content addressing and referencing back. We only do it at a file level, partly because processing diffs is computationally intensive and does not handle corruption well. So it's quick and efficient. We do delta duplication or support it, but you don't have to. You can store objects in their entirety in every version if you wish. And if you have storage that does deduplication under the hood, that may be a choice you wish to take. OCFL will allow that, allows you to capture that. We use JSON for the inventory because it's easy to parse and easy to implement securely. And in most cases, we can capture the entire object and structure and history in a single file. We do encourage people not to create ridiculously large number of versions within OCFL. It is designed for objects at rest, not really for highly dynamic systems. Excuse me. Just have a drink. Right, and stop for questions at the end. I can't see any questions. So where are we with OCFL version 2? Version 1's been out for a while. It's sitting underneath Fedora 6. We're moving towards version 2, but we're moving slowly and cautiously. This is a digital preservation standard. Therefore, it shouldn't need to move quickly. Stability is one of the things we're looking for. So we are moving towards version 2, but it's a very cautious process. Also, it's entirely a volunteer effort. So we have day jobs and other stuff to do. So with community feedback, there were a whole load of use cases submitted into the GitHub repository in the year since OCFL version 1 has been released. We went through, we refined those, we collected some together, deduplicated, and then we put those various use cases to the community. There was a voting process. And what came out of this is really we're going to focus on 6 key use cases for version 2. One is to support physical file level deletion. OCFL version 1 assumes that objects are immutable, but there may be clear legal reasons to require a file to be expunged entirely from the history of an object, and we should not require you to rewrite the object in its entirety, which is kind of what you have to do with version 1. Um, then this is for very large objects, which may have diverging histories, the ability to support version forking. So if we have a very large object, which at some point develops two new versions which are different in their content, we may not want to replicate the entire version history within those two objects. So it's essentially allow two objects to share the same history up to a certain point. And that was a requirement from the Invenio RDM community, who produced the platform that sits under the Zenodo repository at CERN. They do have some largish objects. Um, Looking at packaging per version, so allowing versions to be zipped up, partly for efficiency within some storage systems like object stores, but partly to allow migration and for a number of other reasons. Um, Collapsing OCFL object versions, so the ability um, in the future um, to delete a number of intervening versions of an object, to say, okay, we've decided that actually version 3 to 5 of an object aren't very interesting. We'd like to just remove those from the version history. How do you do that in a way that maintains some degree of referential integrity, so you can come back and say, yes, those files did used to be part of the object, but they're no longer there. So that needs a little bit more information in the object. And again, this is slightly flexing with the idea of object immutability that came in version 1. But again, that's an efficiency requirement. Flagging file loss and file corruption. Oh, there's a typo on that slide. This comes because increasingly we're starting to see some new technologies emerging which are write-only media, and therefore there's a chance that we'll be dealing with media where there is a certain level of corruption. We would like to create new versions of the object, but indicate in some way that some files in an earlier version have gone missing in some way or are damaged in some way. So cover damage while still allowing OCFL to be used and continue to function. And then finally, there was some discussion of application profiles, which says, wouldn't it be nice if OCFL did have a stronger opinion as to what an object should comprise, what is contained in an object? And our response to that is, yes, we can support that. We have an extension mechanism where you can describe, if you have an opinion as to what an object is, what that opinion is. But for version 2, we will probably introduce a little bit more formalism into that type of extension, but it won't actually be part of the core OCFL specification. So we've got 6 use cases, and after thinking about these for a while, we had a couple of meetings online and at various conferences, I think at Open Repositories. We spent a couple of days alongside the conference working on the specification. These 6 use cases gave rise to really 4 fundamental changes to the OCFL specification. And we decided that application profiles won't actually involve a change to the specification, but the result in the defining of a particular type of extension, which already sits within the mechanism that we have. All of this has been based on community feedback. And we also made some consideration as to whether things fitted within OCFL sort of ethos and mindset before deciding whether they would be adopted. Anyway, everything's on GitHub, so do come along to meetings or whatever, and we'll keep you updated on the process on that. There's one update since the presentation I gave at the Fedora camp, which said we were hoping to get something out by the end of this year, but frankly, that's not going to happen. Everybody's very busy. All of my other co-editors are based in the US, where things are quite busy in the library world right now. So realistically, it's going to be Q1, Q2, 2026, I should say, before we actually get probably a draft version of the spec out by that point. So what are the new features that meet those use cases? The first one is these use cases require us to break the assumptions of OCFL version 1, especially as far as object mutability goes, and in the case of content linking, object encapsulation, the fact that an object's completely self-contained. Therefore, there ought to be some flag in the storage root which says not only does this storage root implement OCFL version 2, but it implements the following features which break OCFL version 1 assumptions. On package per version, it kind of breaks object version immutability in that, but in a very specific way, in that the files that make up the object do not change, but the way those files are stored on disk does. What we decided is to make life easy. A version will either be packaged or not packaged. So there's effectively a single package for each version if it is packaged. But if, in the case of zip, for example, or you're hitting file system size limitations, it may be a multi-part package. That's okay. The inventory itself will remain unchanged, so that whether you package a version is packaged or unpackaged, effectively is transparent as far as OCFL validation goes. And what that means is the packaging information has to go in a separate file, which sits alongside the inventory. Content linking is basically how we're going to implement version forking, and that breaks object encapsulation because it allows an OCFL object to inherit files from another OCFL object. We decided to make the mechanism generic and not restrict you to inheriting files from a single object, with the proviso that inheriting files from multiple objects is very dangerous. So there will be warnings in the implementation notes. But it means we can inherit an entire version history, or we can inherit selected files from an object. And there may be an argument, for example, say we have a license that's shared by all the objects in a repository. Maybe all the objects inherit that from an intellectual property object that's stored once within the system. So we saw other use cases for that mechanism. So content linking is how we're going to do version forking within OCFL. And finally, tombstoning, which allows us to actually implement a number of the use cases. Breaks version immutability because basically we can put tombstones in for files that are either not there, they've been lost, they've been deleted, or they've been corrupted. And we can also use tombstones if we have removed entire versions of the object as well. So designing a common mechanism to handle all of those use cases. Again, it's about efficiency and about ease of use. Now, the thing about tombstoning is we've added another couple of features that make the effect of file deletion or file corruption a little bit more complex to handle, namely content linking and packaging. So there needs to be a little bit of thought about exactly how this is implemented to allow for the fact a package may be corrupted or the file may be corrupted in linked content rather than in the object itself. So there's a little bit of nuance around that mechanism, but that's one of the things we're working on. So that's it really as far as the state of OCFL version 2. Just as a final slide, who are the Open Preservation Foundation. We're another membership-based organization that develops open source software. I'm not going to tread on Aaron's toes too much, but if you use Preservica or Rosetta or Archivematica, the chances are you use some of our code in there as part of object validation and stuff like that. And under that umbrella, I also do my OCFL work and a bunch of other things. But that's it essentially from me. Any questions? I'll stop sharing.
Thanks, Neil. Question in the chat. Extension 0008 schema registry. What's the status of the extensions and any chance this can be included or this will be included in version 2? Does Fedora have any plans to support this?
Hi, so this was me. Yeah, it was just about in the past we have had, and given the recent shutdown, instances where, for example, the Library of Congress is offline. And some of our schemas were hosted there, and then we can't really validate things and we can't do processing. So I'm gather that that's what this extension is about, so that there are no external dependencies.
Yes, that's right.
And we thought, oh, that's a great idea, but it didn't seem, I searched and searched, and Fedora, there didn't seem to be any chat about Fedora supporting this. So unless it was supported by the applications that sit on top of it, it didn't really help us that much. But anyway, over to you.
Yeah, I cannot possibly answer that. I mean, it is an extension and it's available in OCFL, but its support in or out of Fedora is outside of my purview. It is there, and yes, that is one of the use cases it was designed for. It's not the first time the Library of Congress has shut down and our XML validation has ground to a halt. So this is one way around it, and that actually came from the Invenio community as well.
And what's the status of extensions? I don't quite understand. Are they kind of use cases which may be carried on into future versions, or?
An extension should continue to work in future versions of OCFL, and they are literally that extension so that they add functionality to OCFL. OCFL itself is pretty lean and pretty minimal, but they describe particular implementations and details specific there. So all extension 8 will still work in version 2, but it's up to the overlying software which extensions they use. Fedora uses mutable head, for example, but it's up to those to say what they require.
Great, thank you.
And one more question in the chat, and then we'll move on. And if there are any other questions, you can continue to put them in the chat, and we can answer them, or we can move them over to Slack. Yeah. But Yuri was just curious. In version 2, is packaging the only option to reduce the number of files?
Well, you can put less files in the object. Basically, yes. If you want to have all the files that you have in the object and all the versions of the object, you kind of have to have the files somewhere. So packaging is one of the ways of doing it. There are other ways that could reduce the number of files. So we now, in version 2, will support the ability to effectively purge files from the object if we've decided you don't need them, using the tombstoning mechanism. And if files can be duplicated within between objects, then you can use content linking to do that. But ultimately, the files in the object are the files in the object. There's not much we can do about that. As I said, OCFL is designed for preservation. It's not designed for, ideally, transactional object managing. That's where something like mutable head comes in.
Awesome. Thank you. And I don't want to cut the conversation down, but we will move on. There is another question in the chat for Fedora or OCFL folks.
That is a Fedora question as well.
Yes,
so
exactly.
I will defer to the Fedora community on that one. Okay, thank you very much.
Thanks, Neil.